Before we talk about how atoms bind together, we must introduce the concept of an ion. A neutral atom has as many electrons around the nucleus as it has protons in the nucleus. An ion is an atom that has lost one or more electrons or that has gained one or more electrons. A proton has a positive charge that is equal in magnitude to the negative charge of an electron. If an atom loses one or more electrons, the number of the remaining electrons around the nucleus is smaller than the number of protons in the nucleus. So the overall charge of the resulting ion is positive. Positive ions are called cations. If an atom gains one or more electrons, the total number of electrons around the nucleus becomes greater than the number of protons in the nucleus. So the overall charge of the ion is negative. Negative ions are called anions. Students sometimes confuse the charges of cations and anions. A useful mnemonic is cats have paws and cations are positive. The chemical identity of an element is defined by the number of protons in the nuclei of its atoms, not by the number of electrons around the nucleus. When an atom gains or loses electrons and becomes an ion, its chemical identity does not change. It is an ion of the same chemical element as the original atom. For instance, if a sodium atom, atomic number 11, loses its only valence electron, it becomes a sodium plus cation. The plus sign indicates that the ion has a positive charge equal in magnitude to the charge of one electron. This ion only has 10 electrons, and they are arranged in orbitals in the same way as they would be arranged for the neutral atom with 10 electrons, neon. However, the cation has 11 protons in its nucleus. So it is a sodium, not a neon cation. If a magnesium atom, atomic number 12, loses its 2 valence electrons, it becomes a magnesium 2 plus cation. The superscript 2 plus indicates that the ion has a positive charge equal in magnitude to twice the charge of an electron. This ion also only has 10 electrons, but it still has 12 protons in its nucleus, so it is a magnesium cation. As you can see, electron configurations for ions can be written in the same way that they are written for neutral atoms, but we enclose them in square brackets and indicate the charge of the ion in the superscript. Similarly, if a fluorine atom, atomic number 9, gains an extra electron, it becomes an F- anion. The minus sign indicates that the ion has a negative charge equal to the charge of one electron. This ion has 10 electrons, and they are arranged in orbitals in the same way as they would be arranged for the neutral atom with 10 electrons, neon. However, it only has 9 protons in its nucleus, so it is a fluorine, not a neon anion. If an oxygen atom gains 2 extra electrons, it becomes an O2- anion, where the superscript 2- indicates that the ion has a negative charge equal to twice the charge of an electron. This ion also has 10 electrons, but it still has 8 protons in its nucleus, so it is an oxygen anion. When alkali metals form ions, their atoms lose their only valence electrons and form cations with a plus charge. When alkaline earth metals form ions, their atoms lose their 2 valence electrons and form cations with a 2+ charge. The heaviest alkali metal, francium, and the heaviest alkaline earth metal, radium, are exceptions to this rule, but we will not talk about them in this class. When 3 post-transition metals in group 13, aluminum, gallium, and indium, form ions, their atoms lose their 3 valence electrons and form cations with a 3+ charge. All other metals also form cations, but their atoms may lose varying numbers of electrons, so one does not immediately know what the charge of their cations is. When halogens form ions, their atoms gain 1 extra electron and form anions with a minus charge. The 2 heaviest halogens, astatine and tennessine, are exceptions to this rule, but we will not talk about them in this class. When the nonmetals in group 16, oxygen, sulfur, and selenium, as well as the metalloids that follow them in the 4th period of that group, tellurium, form ions, their atoms gain 2 extra electrons and form anions with a 2- charge. When nitrogen forms ions, its atoms gain 3 extra electrons and form anions with a 3- charge. Other nonmetals and metalloids may gain or lose various numbers of electrons, so the charges for the ions that they form are not immediately evident.